Okay, so we have found derivatives now, and we've used them to find slopes of tangent lines at points, and then we use that to write equations of those tangent lines at those points. And so kind of much of the same, we'll do a few more examples, but understand what you are doing. Don't just be satisfied and say, oh, I know how to do this, but understand what you're finding as well. And that's an important question to ask yourself as you go through this course, not just being able to do something. Don't get excited about that. Understand what you're doing. That's a big thing. So example 4, find the derivative of f for f of x equals the square root of x, and determine, now understand what this means, f prime of 3 and f prime of 25. What this is asking is, find the slope of the tangent line of f of x at 3. So it's just another way of basically asking this question here, where it said find g prime of x at 1, 3. They could have just as well have said find g prime of 1. That's just another way they could have posed the question, and find g prime of 3. So it's just a different way. You'll see the notation. It means find the derivative at 3. So for example 4, find f prime of x for f of x equals square root of x. Determine f prime of 3 and f prime of 25. Well, let's find the derivative of this first. Let's find the derivative of the function. So we're going to have the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. And now we're going to plug our stuff in. So we're going to plug x plus delta x where the x is. So we have limit as delta x approaches 0. And we're going to have the square root of and input x plus delta x. So the square root of x plus delta x minus f of x, so minus square root of x over delta x. And then we go to plug 0 in for the delta x's, and that sucks because we get 0 over 0. Not good. So we see a radical here. This is actually what number 1 on your quiz was the other day, where you now need to rationalize the numerator to deal with this situation. So we're going to multiply by square root of x plus delta x plus square root of x over x plus delta x plus square root of x. So we have the limit as delta x approaches 0. Multiply the top, so you're going to get x plus delta x minus x over delta x times square root of x plus delta x plus square root of x. Remember, don't distribute it because you want it to cancel out here in a second. So the x's cancel out. Delta x over delta x, you can cancel that out. That becomes a 1. So now you can plug the 0 in. So now you're plugging it in, so the limit goes away. So this equals 1 over square root of x plus square root of x, which is 1 over 2 square root of x. So this is what f prime of x is. This is basically the derivative right here. This is the derivative of the original function. This will find you the slopes of tangent lines at specific values. So we want to find f prime of 3, which means plug 3 into the function. So 1 over 2 square root of 3. This is the slope of the tangent line at 3. And find f prime of 25. So plug 25 in. So you have 1 over 2 square root of 25, which is, well, that's 5. So 1 over 2 times 5 is 10. And that's the slope of the tangent line at 25. All right. Example 5. Given this function, where does the derivative equal negative 1/9? So this is another different question. Previously, we've been asked to find the derivative at an x value. Now I want to know at what x value does the derivative equal negative 1/9? So it's a different question. But we're going to start by finding the derivative of this function. I want to find the derivative of this. So I want to find f prime of x. All right, so f prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. So this right here is going to find the derivative of the function. So let's input x plus delta x where the x is. So limit delta x approaches 0. 1 over x plus delta x minus 1 over x over delta x. So now we have a different situation here. The other one, we had to rationalize the numerator. Now we have a complex fraction. And we've dealt with this. We've done problems like this already. This was why we did some of these practices leading up to this. So we need to combine these fractions on top, which means the first fraction I'm going to multiply by x over x. And the second one I'm going to multiply by x plus delta x over x plus delta x. Trying to get common denominators to be able to combine those. Okay, so I have the limit as delta x approaches 0. Well, I can combine these fractions on top now. So I'm going to have x minus this quantity. Now be careful with your signs. You have x minus, and then that negative goes to both of these. The way you could write this is x minus delta x. Oftentimes a big red flag, people make this a plus. They do x minus x, and then they just put positive delta x. But it's a minus, the negative goes to it. Over this bottom row here, x times x plus delta x over delta x. So now you have that triple-decker fraction, and this is where I've said that tip. If you have this triple-decker, you can actually take this bottom row and put it right up here, and we've talked about why, but it's a nice little trick. And so your x's cancel. You're going to have delta x right here. I'll write it here, delta x. So those cancel. So you really have negative 1 on top. Let me write this down here. I'm getting a little sloppy. So you have negative 1 on top. On bottom, you're going to have x and then x plus delta x. Now you can plug 0 in for delta x, and you don't get 0 in the denominator anymore. You're just going to get negative 1 over x squared. So this right here is the derivative of 1 over x. Negative 1 over x squared is the derivative of 1 over x. So we want to find out what x value makes this equal negative 1/9. So we're going to set this equal to negative 1/9. I want to know what x value makes negative 1 over x squared equal to negative 1/9. And so you just need to be able, I would cross multiply maybe. You can make them both positive, multiply both sides by negative 1. And think about a proportion, cross multiply. So x squared equals 9. Square root. So x equals, be careful, anytime you square root, plus or minus. So it said, where does the derivative equal negative 1/9? At the x values of 3 and negative 3. So when x is 3, the slope of the tangent line is negative 1/9. When x is negative 3, slope of the tangent line is negative 1/9. All right, last question. Long notes, I know. Hopefully it's making sense. Great e-learning day, baby. What are the equations of the tangent lines when the slope is negative 1/9? So we want the equations now, meaning we want point slope form. So think about what you need to write the equation of a line. You need the slope. Well, we know that. So we know negative 1/9 is the slope. And then we need a point. Right here we found the x coordinates where it's going to happen. Notice this says the equations of the tangent lines. There's 2 because we have an x value at 3. So think about what y value you get at 3 because we need the point. So at 3, think about what the y value is. So to find the y value, plug 3 back into the original function. If you plug 3 into f of x here, you get 1/3. That means the y value is 1/3. So at this point, you know the slope is negative 1/9, so you can write the equation. Y minus 1/3 equals the slope, negative 1/9, x minus 3. That's the equation of the tangent line when the slope's negative 1/9. But we have another point. We have an x value of negative 3. So at negative 3, let's see what the y value is. Plug negative 3 into the function, you get negative 1/3. The slope was also negative 1/9. So you have y minus negative 1/3, so y plus 1/3 equals negative 1/9 x plus 3. Good stuff. So if you know the shortcuts to find derivatives, do not use that shortcut. Get used to using the limit definition. You will be asked. to do that, especially on the assignment. They'll ask you to use the definition of derivative using limits instead of using the shortcut. And we'll do this for 1 or 2 more classes, but there are shortcuts to find these derivatives. You're not going to have to go through this process every time. And then people are like, well, why are we learning it then? Because in calculus, you're trying to figure out what are you actually doing? What is the derivative doing and why does it work? And it's the idea of limits. We're trying to get that change in x really close to 0, but still using slope. That's the whole idea that we're doing, okay? So good luck on your assignment. If you have any questions, shoot me an email. Good luck.